All right, so let's talk about properties of definite integrals. Properties of definite integrals, and so the first one is actually, let's put BA here. Okay, so if A and B are switched, remember you calculate this by saying capital F of A minus capital F of B, just like that, right? But that's same as minus of F of B minus F of A. And this one is integral from A to B. So that's what you're going to get. Another property is you have, if you integrate from A to B to B to C, well, to understand this formula, you have to draw a picture. So if you have a function, and here's A, here's C, and B is somewhere in between, the integral from A to B will be this area, right? Integral from B to C will be this area. And if you add them together, you get an integral from where to where? A to C. That's what's going to happen. And a third one is that if f of x is negative on A to B, then integral of f of x dx from A to B would be negative. Now, earlier in the discussion, I said let's limit our discussion only to the case where function is positive, because it gets more complicated if you allow negative functions. So this one I want to explain by drawing a graph. So let's say your function is negative from A to B. Here's how you think about the area under the x-axis. When the function falls below the x-axis, well, first, the area at A is 0 because it's just one point, right? But as you move right and extend this area from A to some value, as you increase, what's getting accumulated? Your function values are being accumulated, right? And those values are negative. So what are you adding? You're adding these negative values, and therefore if you integrate from A to B, the result will be a negative value. Now what that means is that when you allow a function to be positive and negative, so let me just say it here. If you have a function that's positive in some places and negative in some places, the ones that are above the x-axis will be considered as positive area, and the ones that are below, it'll be the value of the integral will be negative of the area. Right? So this, I just said area under the curve. That's only true if f is positive. If f is sometimes negative and sometimes positive, this has the meaning of net area, where f of x negative implies negative area. So when you fall below the x-axis, the value of the integral here is the area calculated, and you subtract. You put a minus sign for it, okay? And you add them up. That's called the net area. Okay? So I'll give you a few examples using that argument as well. That's all for today.